So we are going to be looking at the fits that we need to compare and to determine for our Machinist Vise project. So if we look in our Machinist Vise learning plan, you'll notice that I have some handouts here. Now you can find these documents that I'm going to be referring to in a couple different places. First of all, there's the handouts and reference materials, and you'll notice that these last two before the Machinist Vise first draft drawing guides, the last two documents, the print and references, I've got the Machinist Vise fits check sheet in PDF format and in Excel format. On the screen today, I'm going to be using the Excel format and filling that in, but you can do the PDF if you don't want to use Excel, but you'll have to make sure if you fill it in manually, you do need to make sure that I can actually read it. So you're gonna have to scan it separately and upload it. So, but either format is totally fine, however you want to hand it in, but that's where these two documents are that I'm gonna be referencing today. The other place that they are is going to be in the homework assignments. I do have it as part of the Vise Fits check sheet filled in. So this is going to be the Dropbox that you're actually going to put in your filled in check sheet. And here are the two versions of that spreadsheet as well, the PDF form and then also the Excel spreadsheet. So just by simply clicking on this, you will download it to your downloads folder and then you can pull it up. So I am going to do that right now. And what I'm going to do is I'm going to pull it up in Excel. So same format as what I just did right now. Just click on the actual file. And I am going to maximize it and I'm going to enable editing. So this is the Excel sheet that you're going to be looking at. Now, what I've done is I've done some descriptions along the way here. And this lecture is going to be getting you started on this process. We're going to do this in 2 meetings because it takes a little while. So by going through both of my lectures, you will have all of the information to fill this in. So we're going to kind of do it together, okay? So, let's start at the top here. So what I've done is I've given some brief descriptions, but they might mean more to me than they do to you. So what I wanted to do was to make sure that you knew what each one of these meant and go through the process of figuring this out. So on my spreadsheet here, I've got some columns. So I've got nominal dimension, I've got the high value, the low value, maximum clearance, minimum clearance, max and min interference, and then will we be accepting or rejecting, okay? So as we go through and we look at the pictorial view of each one of the parts in this vise, the document that I gave you had some suggestions for the actual fits already. And as you were creating your first draft models and drawings, I told you, don't worry about those right now. Just do nominal values. So you may have, depending on what the value was, you may have picked the high value, the low value, or something in the middle, for instance, or something that made sense to what we call a basic size. And that could have varied. You know, if you used my drawing guides, you would have used those values potentially. But if you came up with your own, that's totally fine too, as long as they kind of made sense to the dimension. But now we're going to go back and we're going to look at those where we see the actual, numbers or the fits or the limits, and we're going to check them. We're going to see, does it make sense with, what it's going to fit with if those are going to work. So we're going to use the ones that are given on our sheet, which is this guy right here. We're going to use those first and then determine if we're going to, accept or reject those and then change them up as needed. So we're going to find that many of them we do use, and then we might actually change some of the other ones. So this process, as we go through it, you are going to, you're going to kind of see how we develop this. Now, part of a full set of working drawings is going through and determining what the tolerances are. Now we know that each one of our dimensions on a drawing has a tolerance, whether it's specified or not. So for instance, I'm going to go underneath my document camera here. If we look at the base, okay, and the first dimension we're going to look at on the base is going to be this 1-inch dimension here on the cutout that's going down the entire length of that base. In that cutout, our sliding jaw is going to fit down in there, and its dimension right here, which is 0.998 to 0.996, I know it's kind of hard to see on here, okay, is this overall width here that's going to fit down into that cutout or that groove in our base, okay? So we want to see what that number is going to be. Now, in this case, they both have limits associated with them, but if we have, for instance, any one of the other dimensions that might just be to 1 or 2 decimal places, we know that we default to the title block. So as we look at our base drawing, we'll notice that in the title block, I know it's really hard to read here, this is a B-size drawing, that for 2 decimal places, it's plus or minus 20 thousandths, and for 3 decimal places, it's plus or minus 5 thousandths. So if we have a dimension on here, for instance, that just is 1.5 inches, it has a tolerance, even though if we don't show the limits on it, it defaults to whatever the title block has in there, okay? So every dimension on a drawing does have a tolerance, and you as the designer need to be aware of that. If the title block tolerance doesn't apply, we need to specifically show it on our drawing, okay? And that's what we're doing. So first draft, we said, okay, they're all gonna be whatever they were on the drawing. So if there was a 2-place decimal or a 3-place decimal called out, we showed them as 2 and 3-place decimals here, but as nominal values. Now we're gonna go back and we're gonna look at these fits and see, okay, how does this all come out? Okay, how does this work? So on our spreadsheet, let's go back over here. On our spreadsheet, let's look at the first dimension that we're interested in, and it's the one that I had just looked at. So it's going to be the dimension for the Vise base and that sliding jaw and how they kind of fit together. Okay, so the nominal dimension for each one of them is 1 inch. That's in the first column here. Then our next column, I want to put in what the high and the low values were. So we're going to go back to that pictorial view, and we are going to find the limits that they specified. So I got to go back here. And on our base, our limits were a high of 1.004 and a low of 1 inch. And on our sliding jaw, they were 0.998 to 0.996, okay? Now again, as we look at the value that we would have had on the drawing, we would have put 1 inch here, and we have 1 inch here. All right, so those are the nominal values that we drew it to, but we want to see, are these guys the ones that we want to use? Okay, so let's compare. So if we look at the base, the high value is the 1.004 to 1 inch, and on that sliding jaw, the high value is 0.998 to 0.996. So when we look here now, what I've done is I have highlighted in yellow the two that we're going to compare for the maximum clearance. So for maximum clearance, that means that that groove or that width of that cutout in the base is going to be its widest, and then we're going to have that sliding jaw be its thinnest. That's going to give us the most clearance, or maybe the maximum amount of slap, if you would, movement once they are together. So when we subtract these two values, what we're going to get is 0.0. Oopsie, got to click here. 0.008, okay, is going to be the clearance, right? Now, so that's with taking the 1.004 minus the 0.996, okay? Then you'll notice for minimum clearance, that's when our groove is going to be the thinnest, but it's going to have the widest sliding jaw on it. So it's comparing these two values. So it's 1 inch minus 0.998, so that's going to be 0.002, okay? So in both cases, we do have clearance because these are, values that are going to show that they're going to fit, and we don't have interference. Now, as we look at these numbers and we think about how that is going to actually run in here, if we put and we look at how this sits down in there, the movement back and forth is not that critical. Right? So a couple thousandths in the case of 8 to 2 thousandths back and forth, it's going to actually be a really nice fit in there, but you'll feel a little bit of gap, okay? But the operation of this is actually in this direction, and it's really, all about clamping on something and really, getting a good amount of force so that it stays in place in the clamp when you, do whatever else you need to do to it after that fact. So in this case, this direction is not that critical, and we do want it to move freely. So I am going to say, in this case, we will accept both dimensions as they are printed. Now, once we do that, then what we need to do is go to the drawing and fill in those values. So let's go back underneath our drawing, okay? So we're gonna use these two values. We said, yep, that's gonna be something that's good. So instead of 1 inch right here, this is gonna go to 1.004 to 1.000, okay? So when we go and we update this, now I'm not gonna have you update it just yet. We're gonna kind of look at all the dimensions that we may be interested in, because there might be more than one, especially on this one. This base is a little bit more involved. This is going to be one of the dimensions that we need to update. So we'll do them all at once, and that'll be part of what you update for the final drawing. Now, you're just going to go back, you're going to open up, and you're going to change that to the tolerance that we see here, and you have experience doing that, okay? And it's just going to be to those values. Now, we're going to do the same thing on this dimension on our sliding jaw. We are going to change it from 1 inch to 0.998 to 0.996, okay? And that way, that's gonna be a dimension that we need to, change and update for the final draft, okay? So these two are gonna be part of that final draft assignment. All right, so that is the first pair, okay? Now we're gonna do the same thing for the next one. Now we're gonna look at the sliding jaw height and the base height. Now the nominal dimensions here are 0.504 on the sliding jaw, and it's going to be 0.5 on our base, okay, on our base. Now, when we look at the drawing itself, back over here, this is the dimension we're interested in right here, and how it sits with this dimension right here, all right? So it's this guy. Now, if we look on our drawing, I left it off, okay? So we actually need to add it in, and it's going to be this height right here in this view, okay? So what I'm gonna do is we are gonna add it in, and I'm just gonna add it on this side. Whether it ends up in this position on your final drawing or not, I don't know, okay? But this is that dimension that we're going to be looking at. So it's from the top of the carriage, if you would, to the top or the bottom of that cutout, okay? So it's that little ledge right there that we're interested in, okay? 0.5, we want to be sure that it is, or based on the dimensions right here, we have 0.502 to 0.498. Which 0.5 is right in the middle. And then down here, I drew it, the nominal value to 0.504, which is the smallest value to 0.507. So on our spreadsheet, we will notice that we have the high and the low value for our sliding jaw height, so 0.507 to 0.504, and then the base is from 0.502 to 0.498. So our maximum clearance here is going to be when we have our largest number on our sliding jaw with our smallest number on our height. So this number right here is going to be 0.009, okay? Then you'll notice that we have as our minimum clearance, it's going to be when the base height is at its tallest and the sliding jaw is going to be at its minimum, and we're still going to have 2 thousandths of clearance, okay? And that's important because of the fact that we don't want this, we want it riding freely again, back and forth, and we don't want it to get hung up. So these two being a clearance, not crazy amount, but also definitely there, these are two good numbers as well. We're going to accept those, okay? Now, if we would have any interference or it would go to 0, then we would probably want to adjust something. But we've got clearance on both cases to its extremes, so we're going to use the numbers as printed. So on the base drawing itself, okay, on the base drawing itself, we're going to use the accepted values of 0.502 to 0.498. And that I'm going to kind of put up over here to 0.502 to 0.498. going to be that dimension. And then on our sliding jaw, this dimension is actually over here, okay? And this is going to be 0.504 to 0.507. Okay, so those are two dimensions on both the base and the sliding jaw that we need to adjust for our final draft. Okay, so those two are good. Now we're going to look at the sliding jaw and the slide key. Okay, sliding jaw and the slide key. So the slide key itself fits into the two grooves on either side of the part of the sliding jaw that goes down into the base. So we're going to be looking, I'm just trying to get my papers that I need here. Okay, so these two, let's look at the slide key first. Okay, the slide key, let's look at the whole drawing. Right now, the dimension that we're going to look at is going to be the 0.185. Okay, 0.185. So it's the thickness here. This is going to sit inside of our jaw right here. Okay, so this height right here, 0.188 on our sliding jaw, is going to receive this dimension right here. So this sits, if you would, horizontally in this orientation into that groove. Okay, so there's going to be one on this side, and it's gonna sit in here like this. Okay, and it's going to go out to the edge, and then it's going to go beyond out on this side as well. Okay, so we want to look first at that dimension, that thickness. Okay, now if we look at the dimension that's given here on our print, on our sliding jaw, we have a height dimension from 0.188 to 0.187. It's pretty critical. And then on our key, we have a dimension of 0.186 to 0.185. Okay, so these two values for the key and for our sliding jaw, we will find in our spreadsheet. Okay, the high and the low values for each. Okay, so now to find the maximum clearance and minimum clearance, we're going to take on the sliding jaw the tallest groove height. Okay, the tallest groove height, and that's 0.188. And we're going to compare it to the smallest height on that slide key. So that's going to be 0.185. So the difference there is going to be 0.003. 0.003. And then when we compare our shortest groove height to our shortest key height, we're going to notice we have 1/1000ths difference, and both of them are clearances. Okay, so in this case it's going to be fitting in there nice and snugly. Okay, now there is clearance, but based on the length of this, you might have to tap it in a little bit, but that's okay because we want those to stay in place. So we're going to accept each one of these dimensions as well. Okay, so now we need to update our drawing. Okay, so we're going to go over and we're going to go underneath, and this dimension is going to go from 0.185 to 0.186, 0.186. So this is our new dimension, and on our sliding jaw, this is 0.188 to 0.187. That's going to be our number there. Okay, all right, so another dimension updated. Okay, so the next one that we're going to be looking at is we're going to be looking at the slide key width compared to the sliding jaw slot. Okay, and what we want to do here is we are going to be looking at, this is kind of a three-part process. We're going to be looking at determining how far out those keys are going to be. So if we look back over here, these are going to be sitting on the outside here. All right, we want to determine how far out is that actually going to sit from the side. So, oopsie, I'm going to go in a little bit. We want to know min and max from the edge, how far out that's going to be. Okay, how far out that's going to be. And we do that by looking at and comparing the sliding jaw slot depth and the width as it sits there over its overall length. Okay. So when this sits in place here, the dimension that is going to stick out is going to be this one right here, okay, the overall height, And we want to know how far out of that depth of 0.218, how far is that sticking out either on one side or on the other, okay, min and max. So we are going to compare those two dimensions. So as we look at those two dimensions on our pictorial, the dimension on the slide key is the 0.341 to 0.340, right there. And then on our sliding jaw, our dimension is going to be 0.219 to 0.217. Okay? So if we go back to our Excel spreadsheet, you'll notice that 0.219 to 0.217 are here on the sliding jaw slot, that depth. And then the slide key width is the 0.341 to 0.340. Now, what we want to do is we want to compare each one of these to see the maximum amount out. So that's going to be when the slide key is its longest, if you would, as it sits in there, and when the slot is its shallowest. So that dimension here is going to be 0.124, okay? And then you'll notice that when we compare the opposites, so when we compare the slot at its widest or its deepest, and then the key at its thinnest or shallowest, we're going to get 0.121. Okay. All right. Now that's how much it's sticking out. That's what I want to know here. So now what I want to determine is what is the total width with the actual key. So what I want to know is what is the width? What is the width when I have both keys in place and they're inside of the width here? Okay, so that's going to be combining the dimension here to how much is sticking out on each side. Okay, how much is sticking out on each side. So when we look at this width, this is going to be the 0.998, the 0.996. I'll go back over here to my Excel spreadsheet. I'm going to find that width by taking the jaw max width. Okay, so I'm going to put this number over here. That's going to be the 0.998 plus 2 times the maximum out. So that's going to be times 0.124. Okay, all right, and that is going to be the value that I have for my, what would be the maximum, 1, 2, 4, the maximum amount of width on the outside. Okay, whoopsie, 0.2, okay. 1.246. Okay, now actually I should put this over here. Cut over there. And we'll put it like to the left here. Oopsie. Left. There we go. And I'll put an equal sign in front of it. Okay. All right, so that's how we get that value. Now on the next one, we want to know what the minimum width is. So that's going to be when my jaw is the thinnest and when I have the least amount of overhang or the minimum out. So that's going to be equal to, it's going to be 0.996 plus 2 times 0.121. Okay, and I just want to make sure that I can see this over there. And that total value is going to be 1.238. Okay, so this is the range with the key in place, how far that's going to be hanging out. Now, what I want to make sure of is that number is going to fit over here. It's going to fit inside of here, okay? Because I need to get that key underneath in the inside, the key over here on the inside, and my total jaw in the middle there, okay? But I have to make sure that it doesn't go too far out, right? So I have to make sure that it fits within the confines of this dimension right here, okay? The 1.254 to 1.250. So if I go back to my spreadsheet, I have my base dimension here is 1.240, 1.254 to 1.250, talk slower here, and my slide width, the high value is going to be the 1.246, and the low value is going to be the 1.238, okay? So now I'm going to compare my two values. So I'm going to look, okay, is there clearance here? Is there clearance here? So when I look here, it's going to be this guy, this one's going to be the green. So my clearance is going to come from here to here again. So I'm going to have 16 thousandths, 0.016 here. And then minimum clearance is going to be 4 thousandths, okay? That's good. I've got clearance all the way down, all right? And that is good. So you'll notice here, I don't know why I have colors in these guys. We're going to take those out. They are not needed. So when I look at the base width here, this dimension right here is going to be an accept, because the numbers down on the bottom there are a derive, okay? So that means I'm going to use the 1.254 to 1.250 as my base dimension width on that 1.125 nominal value. So if I go back over here and I get my base out, this number right here is going to go to 1.250 to 1.254. 1.254. I'm going to put a little cloud around that. Okay, it's kind of little, but I know I have to change it. Okay, so that one is confirmed. That's the next one. Okay, cool. Now what I'm going to do is I'm going to go down to the next value. Okay, so I got to catch myself up on my sheet here. I'm going to now look at that one done, the slide key cutout and the screw, the set screw diameter. The slide key cutout and the set screw diameter. So as we know, our set screw that we're creating is going to fit up in the cutout of our slide key, okay, of our slide key. So if I kind of look here, I'll kind of show us. All right, our set screw is going to fit up in here. All right, and it's going to extend out into this groove. Into that groove, then this area right here is where that set screw is going to sit. Okay, so as we look, if you would, that set screw is going to sit in there, kind of half and half. It's not going to be completely. It's going to be like something like this, and that is what's going to keep it in line down the slot of the base, okay, the slot of the base. So this is where our set screw is going to be in. So we want to make sure that the width of this is going to accommodate the diameter of the set screw that is going to be up through there, okay? So if we look at the dimensions that are given here, our set screw diameter on the portion that's going to fit in there is identified as 0.142 to 0.140. And the width of our cutout is 0.156, 3 decimal places. So there is no limits specified here on our pictorial for our slide key. So what we're going to do is we're going to apply then the title block tolerance. So you'll notice here for the slide key width, wait, am I on the right one here? For the slide key, no. For the slide key cutout, 0.156 is the nominal value. We are going to add 5 thousandths and we're going to subtract 5 thousandths. So the total difference here is to 0.161 to 0.151 using the title block tolerance plus or minus 5 thousandths. The set screw diameter goes from 0.142 to 0.140. Those are limits that are on our pictorial. So we'll use those. So now what we're going to do is we're going to find that there is 21 thousandths of maximum clearance and 9 thousandths of minimum clearance, okay? So since there's clearance in both cases, that is going to fit in there. I can put an accept on both of those. Now, the only one that is going to require us to add limits to is going to be the set screw diameter. So if I go back underneath, my set screw is going to go from 0.140 to 0.142, okay? And my groove here is 3 decimal places, so this stays as is. It's all good, okay, and it's checked out. Oh, did I do this guy? Now I'm gonna look back. I don't think I updated that one. Shoots. We determined that it was okay, right? 0.340, 0.341. I think I forgot to do that. So that was good. Did we do the depth? Shoots, I know I accepted them. So the depth here, this one right here, the depth going in was 0.219 to 0.217. 0.219 to 0.217. We accepted it on our spreadsheet, but we forgot to accept it and change our dimension. So make sure that we update that based on the 0.340 and that guy on from our spreadsheet when we looked at this one right here. So this is good and that is good. I forgot to update our drawing from there. Okay, so that is as far as I want to go today. I want to get you started on this. Now, I will be continuing on tomorrow and doing a demonstration of, there's 3 of them down here that we kind of go through, and I want to make sure that you understand those especially, but I want you to also look down below and start filling in. Some of the fields I have filled in, some of them I don't, but make sure that you can understand where the numbers are coming from and then attempt to fill in the ones that seem to make sense, okay? I know you might have questions on some of like what I'm calling things, but that's okay. Okay, we will be going over it together, but I wanted to get you started on it, and then we're going to continue on tomorrow, okay, during our next lecture. All right, so what I'm going to do here is I am just going to stop sharing, and then I'm going to stop recording.